Hello everyone, welcome back to the channel. I hope you guys are doing amazing. Today's daily challenge on Leetcode is a bit difficult one. So I will only request you to stay till the end of the video, and I will try my best to explain you as simply as possible. And also I am teaching a DP from very basics to advanced. Okay, you can follow my DP playlist in my channel. It will definitely help you for your placement exams. Let's just start. Let's just start with the videos. Okay. Let's see the problem. Find the original type string 2. So this is the second version of the problem. You can go through yesterday's problem also. It's somewhat similar, an easier version of this. And the question goes as follows: the Alice is attempting to type a specific string on her computer. However, she tends to be clumsy and may press a key for too long, resulting in a character being typed multiple times. Okay, so you are given a string word which represents the final output that is displayed on the Alice screen. Okay, Alice's screen. So you are also given a positive integer k, and you need to return the total number of possible original string that Alice might have intended to type if she was trying to type a string of size at least k. And you need to return modulo 1e9 plus 7. So I will forget it. So I will just quickly write this here. LL mod 1e9 plus 7. Okay. So I will use this mod, uh, and I will use this has defined long long. Okay. Let's start with the intuition. You try to see that given a string, there can be many possible arrangements of it. What do I mean by arrangements? That's what exactly is Alice wanting to type. There can be many such possible outcomes for that, and you need to find the number of outcomes given some constraint k. That is, the size of the string must be k or greater than k. That means that it must be at least k. Let's try to see a very small example. Okay, very small example I will take and try to tell you that what will be the all possible combinations. So if you see this string and you try to tell me that what could have been the all the possible combinations without any restriction, without any kind of restriction, if Alice would have wanted to type, what all the things could she have typed? First of all, it is possible that she would have typed this exact same string. Okay, then she might have typed a string with only single A. Okay, you got it. You got it, I guess. Then it might have been possible that Alice would have wanted to type AA and then two B's and then AA and then a single B. Okay, and it is also possible that Alice would have wanted to type something like this. Okay, so you see there are total 6 combinations, but do you observe any pattern here, right? There you can decrease b one by one. In this row I have decreased b one by one, and in this row also I have decreased b one by one, and along the column I have decreased a one by one. So what does this mean? This forms a table, right? So if this is also basic combinatorics, just to give an essence I'm telling you like this, but if you see, there are 2 possible choices for A and there are 3 possible choices for B. So total number of combinations would be 2 into 3, 6. I hope you get a basic understanding of why it is this something like this is happening. Okay, I will now go on with a larger string and move further with the intuition. This is the total number. Okay, this is the total number without any restrictions. I have not introduced k at the moment. I had not introduced k. So I just want you to tell me that what will be the total combination. Uh, let's take a big string. Okay, I had taken this string to understand this and solve this. So I will take the same string again. You take 3p, 3a, 4b, 2c, 2d, and again 2b you take. It can be repeated, right? It can be repeated across multiple segments. So what do I need to do now? So you see, I will just ask you to pause the video and tell me how many combinations are there. It's very simple, without any restrictions. Okay. My question is that without any restrictions, how many string can you form? You just tell me quickly. Okay. Uh, use after after thinking properly, you should have easily understood this. It's not difficult at all. Okay, there are three choices here, there are four choices and two choices. So 3 into 4 into 2 into 2 into 2, this is the total number of possible, which is nothing but 12 8s and 96. Okay, so you have 96 total choices without any restrictions. Now what is your restriction? What is exactly your restriction? Let's say your k is something like 9. Your k is something like 9. It means that number of possible sizes of the string should be 9 or greater than 9. Greater than 9. What does the problem statement say? If you try to see, the problem statement says that if she was trying to type a string of size at least k, it means at most any, so 9 or greater than 9. So this is the length of the string which you should ensure, and not this whole length, not this whole length. Okay, so what is the whole length of the string? You see, this is 3 plus 4. So the n, which is the whole length of the string, will nothing but this sum of all this, right? 3 plus 4 plus 2 plus 2 plus 2. So this is the whole length of the string, which is nothing but, if you add it, it is 13, right? Okay, it's 13. This is 7 and this is 6. Okay, so 13. So you see, what do you get now? It should be 9 or greater than 9. So the strings, you can tell me that we need to subtract all the strings which are k or less than k minus 1 or less than that. So what do I mean by it? So number of strings which are 9 or greater than 9. Okay, so that can be also written as total number of strings minus number of strings which are less than 9. Okay, number of strings which are less than 9. Okay, okay, so this is my total required can be written as something like this: total number of string minus number of strings which are less than 9. 9 is nothing but k. Okay, so total number of string which is less than k. Now you try to just visualize this. Okay, try to just visualize this into a segments. Okay, into some segments. What do I mean by segments? It will help us to analyze the problem more clearly. Okay, so if you are asking me questions like how do I know I have to use segments, how do I know I have to use this total minus number of strings possible, so see, these types of ideas would come to your mind with practice. I cannot tell you any shortcut by which using some magic you can just things will come to your mind. So your target should be to solve more and more problems, and that's all. Okay, that's all you need to do, and you will also these things also will click in your mind one day. So now your target should be to understand the approach clearly if you cannot understand this problem. So let's return to the problem. Okay, so you see, try to divide these strings into segments. Okay, you see, what can be the first, you tell me what can be the minimum possible string that Alice would have definitely typed, minimum possible length of the string. Can I tell you that the minimum such length is nothing but A, B, C, D, B? Can Alice type a string shorter than this? You tell me and say that can Alice type a string shorter than this? Answer is no. He cannot type a string which is shorter than this. So at least this is the minimum length of the string. And you see, this min length is nothing but 5. This min length is nothing but 5. Now you see how many additions can you do to this min length at max so that it reaches this string. How many? I am telling you how many additions in each of these letters you can do so that it reaches this string. If I tell you something like I make a segment array, okay? As I told you, I am dividing these into segments. As I'm dividing these into segments. So what do I mean by it is that if A is 2, B is 3, 1, 1, and 1, okay? So what do you mean by this? In original A, at max, you can add 2 A's to make 3A. Okay? The second segment, in the original B, you can add at max 3 B's to make another this clump of segment of B. Okay, you understand this, right? You understand this. So this is the minimum addition per segment which you divide into. Okay, this is the minimum additions per segment which you divide into. Now you view this problem as something that you have a minimum string. I hope you know where this problem is going now, right? You have a minimum string and you want to add something to it. So you want to add some characters, or segment wise you will analyze this segment wise to get some string which is of size, definitely it cannot exceed the original string. Okay, this is my original string. If then this cannot definitely exceed my original string. Now more specifically, I am concerned about finding strings which are less than k, which are of sizes less than k. So you should remember that uh, less than k, I want to find only those strings which are of size less than k. So uh, add some string segment wise. So can I tell again that in this minimum string I am adding some string again, okay, to make a string of size less than k, of size less than k. Okay. Now, one thing which should come to your mind. What if k is 0? What if k is 1? Well, you tell me what if k is 1? Okay. Then what can you do? You tell me here only. What if k is 1? Then it says that the minimum length of the string is 1, but you know the minimum length is 5. You will tell what is happening. It is asking me the minimum length is 1, but I know the maximum feasible minimum length is which is also 5, right? So you can tell that if k is less than or equals to minimum length, then okay, I am telling you that what is this happening? If k is less than or equal to minimum length, you just return total number of operations, total, without subtracting anything. You just return total. Did you understand this, guys? Did you understand this? Try to think and try to think this, that if your k is something like 4 and your question is telling you to form strings which are greater than or equal to 4, you know that you can form only those strings which are just greater than 5. Okay, minimum length is 5, greater than or equal to 5, and let's say the problem is only asking you to do something which is greater than, less than or equal to this minimum length. Then you just return total number of occurrences, right? Then you know that starting from these occurrences, uh, I want to say that starting from this minimum string to this maximum string, you can form many strings, right? As I told you, 3 into 4 into, you can form many such strings. And if you need to return all such strings if the minimum is less than or equal to k, because k gives us the bound, and k is below that, then you return all of the strings. Okay. So this is a very important point which you need to remember, that if k is less than or equal to min length, return total. Now, what if it is not? You definitely need to subtract, and you just need to find how many strings are there which are less than k. So let me return to what I was saying. So add some strings to this minimum string. Add some characters. I want to say that just add some characters based on this segment array. You add some characters in a string of size k. Okay. How to do that? Now, this is a very standard problem. So let's say if you know this, I guess you can already do this. This is a, let's say you are wanting to add something like a b c. These are the segments which you are having, right? These are the segments which you are having. So if, let's say, you want to add x1 elements to a, uh, add x2 elements to b, you can add x3 elements to c, x4, x5, and each of these xi should be less than or equal to segment of I. You can understand, right? This, how many additions you can make? You can make either 0 or 1 or 2. Okay. you can make either in this segment you can either make 0 additions, 1 addition, 2 addition, or 3 additions. Similarly, you can go on with the other segments. And the sum of all xi, summation of all xi should be less than k, less than k. Summation of all xi less than k given the constraint. So this is a constraint equation which can be solved using dp, and this is it is a standard technique. If you already know this, just go ahead with this. Otherwise just stay in the video. I will explain you how exactly this happens, I will explain you in detail. No need to worry about it, no need to worry about it. So if you are following my dp playlist, or if you even have some basic understanding of dp, you already know that there is something known as take not take dp. But is there anything take not take will happen here? You try to think. Not exactly that, but very similar to that. In this segment, you will consider the choices that you will have the possibility of adding 0 element or 1 element, or I will iterate through the segments. I will iterate through the segments and tell you that I may have the possible choices of adding 0 elements or 1 elements or 2 elements for this first segment. And again, you have the possibility of adding 0 element, 1 element, 2 elements, or 3 elements in this from this second segment. Okay, from this second segment. So second segment, nothing was b. So it is equivalent to saying that I can add 0 is okay. So I am forming my final string in which I can add 0 is. I am telling that I can add 1a, it will become 2a. I am telling that I can add 3 is. So these are the various choices which I have, right? And this b also, I can add 0 b's, I can add 2 b's, 1 b, 2 b, and 3 b also I can add to make the total 4 b's. I hope you understand what I am exactly trying to say. It's simple. It's simple. Okay. So I hope now you have easily understood how you need to proceed with the DP. So I will keep a simple 1D DP. Okay, I will keep a simple 1D DP where DP of I denotes nothing but the number of possible choices to form a string, which is number of choices to form string less than from string taking I characters. Okay, taking I characters. So number of choices to form the string taking I characters. Now you see how I will incorporate all these things into the DP. So first of all, you tell me something. You speak up that you want TPK minus 1, right? Number of choices to form the string taking K minus 1 or less. K minus 1, K minus 2. What did I tell you just before some time? Okay, I told you you will subtract something from the total answer, right? What was that something? Total number of string which are less than or equal to k. So you all number of, so dpi denotes number of choices to from string taking I characters. Okay, taking I characters. uh just write it in detail here. Taking I characters, and you are wanting something which you need to subtract from total. Okay, so from total, if you see from total, you will subtract something like this. From total, you subtract something like this. So this is the thing which you want to calculate. Number of choices to form string taking I characters. Okay. Now you tell me. I will iterate through every segment. You easily understood that I will have a loop for obviously for this I will have a loop from I equals to 0 to I equal to k in order to fill the DP. Okay, in order to fill the DP. But can you tell me the transition? Which is very interesting. Okay, very interesting now. Can you tell me the transitions? So I have I was telling that for one segment which has x elements. So now let us take a segment which has x elements. Okay. Now what you are doing is very clear cut to you, is that you are iterating through the segments. Okay, you need to iterate through k also. Then again you need to, but you will update segment wise, right? So for x belongs to segment, so you update through segment. And let's say you are in this segment where the number of characters in that segment is x. So as I just now told you, you can add 0 characters, you can add 1 character, you can add 2 character. You have these choices. All of these choices you need to add up. So you are adding, let's say you are forming DPI. Okay, you are forming DPI. That's cool. That's really cool. If you want to add one character and form DPI, from where you would have jumped to DPI? DPI minus one. If you want to form, uh, if you want to add zero character, you would have jumped from the same state. If you want to add two characters, if you want to add X characters, okay. So what do you understand with this? You just tell me what exactly do you understand by this? It is that if you are forming DPI, the transition is given by nothing but if you want to have, these are the number of characters. These are what does DPI denotes? The string I. Okay, you want to form the string of length I. What will be the number of ways to do that? And from deep, if you can add zero characters, and from this you add one character and form this string. You add from the I minus 2th string. Okay, this is of length, string length I minus 2, right? You add two characters and form DPI. Similarly, what are the choices? Till X you have the choice, because that is the segment value. So by adding all of these, you get DPI. Okay, you get DPI. So now what will you do? Every time will you just do it? If you see what you need to do exactly here is nothing but this is a prefix. This can be calculated using a prefix. So you know that. I hope you know this. Okay, if you are solving this kind of problem, I hope you already know what is meant by prefix and all. So if you are having some arrays, something like this, 6, 8, let's say 1, and you want to find the sum from, let's say, the third element to the fifth element, you can use a prefix sum of your array. So how will that work? You can just keep 2, 5. You just add everything till this index. Okay, the 5 plus 4, 9. 9 plus 6, 15, plus 3, 20, plus 8, 23, plus 1, 24. And you just subtract this 23 minus 5. What will you get? 23 minus 5 is nothing but 18. And you see 4 plus 6 plus 4 plus 8 is nothing but 18. So this is the idea of prefix array. It helps you to find range of answer. So I was hoping you will know this till I just told you that what is the inclusion of prefix. So do you think prefix can be used here? Do you think prefix can be used here? Definitely it can be used. What are you doing this? You are finding a range sum, right? This is nothing but a range sum. So for every DPI, you are going back. You are starting from I minus 1, I minus 2, and going back till I minus x, adding all the DP values into here. So instead of a loop here, keep a prefix. Okay. And why you need to keep a prefix? Because you understood about the time complexity, right? And for every I you need to do this. What is this I? Don't forget what I told you previously. You need to iterate for every I because of this, right? I had already explained you this. What is this happening? Okay, so there was some mess. So whatever, just ignore it. Okay, just ignore it. I will use the delete. Okay, so just ignore it and just focus on what I'm saying. This I goes from 0 to k. So this DP thing you are doing inside this I. Okay, this summation of whatever DP of I minus this j, whatever you are doing, j ranging from 0 to x. You understood this, right? J ranging from 0 to this thing you are doing inside this. So instead of using a loop to calculate this summation, I will use prefix array to calculate that. And everything after you have done all this, you just return total minus sum of all elements of DP. You just do total minus, I have already explained you, total minus sum of all elements of DP till k minus 1. Till k minus 1. So you just iterate through all the elements of DP and till k minus 1. So what you think is that you initialize DP array as k. Don't initialize it something greater, because it is of no use. You are only using these DPs, okay, and you are using only previous states to fill this DP. So using the previous state, you just fill till k minus 1 and just add all those elements and do total. Your answer will run in perfect runtime complexity without any error. So let's try to do the coding part. I guess approach is somewhat clear to you, if not very much, somewhat at least clear to you. So what is the first thing which you need to do? Uh, so let's scroll back and let's see what's the first thing which you need to do. Is that you just see you need to calculate this total. This is very easy. You can anyone can calculate this. You just do it. I will also do so. This without any restriction. You just calculate the total, and now you just then you calculate this total number of strings which are less than or equal to 9, and then you subtract this, and you also need to check this criteria also. Let's start one by one. I will keep a segment array also, as I have told you. So what I will do that, okay, so I will do word dot size. Okay, this is n, which I try to put every time, uh what do I do now? I keep a count for each run, for each of the segment. I will have a count. uh, i have I am obviously iterating through the whole array, right? So that needs to be there. I also keep a vector segment, and I just do you what do you do? Start from one. You start from one. You have already count as one. Okay, and you just go through all the, you do in whatever way you like. Okay, you have understood the method. So you do in whatever way this thing you need to do. You just keep in mind what you exactly need to do is the total one and count is one. So if if now word of I is equals to word of I minus one, what does this mean? My current character is same as my previous character. Just increment the count. I am incrementing my count. Oh, very good. That's very good. And what you need to do more after else if it is not true, it means that I am in the break of a segment. I'm just after the break of a segment. So I will do segment dot pushback count minus one. Remember it. Don't do mistake. Count minus one. Segment, what does segment shows? So what does segment shows? It shows the number of elements which you need to add, right? Not the count, total count. So if a is 3, you add 2 to the segment, because you are in the minimum string you are adding it, right? In the minimum string you are adding it. So you just push count minus 1. You reset your count value to 1, and you need to, before all this, you need to multiply the total, right? Equals to nothing but total into this count. You just multiply it, and this is nothing but long. I just take it long, and definitely we want to put a mod. You want to put a mod here. Okay, don't forget these things, otherwise unnecessarily you will have a wrong summation. So, if you now what you need to do is that it's very simple. You see after the n, you are not adding back the last element, because after every segment you are adding the segment which was just before it. Okay, so what you did here was that you are after iterating through this, you are in B, and then you are adding this segment into my segment array. Then again when you are in C, you are adding this segment. So when you are not adding the last segment, to be very precise. So what you do is very simple. Just add the last segment. Okay, it's very simple. So just do total equals to, just add the same thing. Okay, you just copy this same thing. uh, you just copy this exact same thing. You are adding back, you are doing nothing but adding back the last segment, just pushing the last segment if there remains any. So what you need to do is you need to add this condition. What will be the minimum length? What will be the minimum length? What will be the reduced string? It is nothing but the size of the segment, right? You just check. It's just nothing but the size of the segment. A, B, C, D, B. It is size of every segment. So you just do minimum length of string is nothing but size of the segment dot size. And okay, now you need to put this criteria that if your minimum asked k, if you are constrained it only less than or equals to minimum length, if your constraint k is nothing but less than or equal to minimum length, what do you do? What do you need to do? Okay, I just write in minimum length. Okay, what do you need to do? You just return total. Nothing you need to do. just return total. You don't need to subtract anything. Now comes the point of subtracting thing. So you covers, as I told you, you keep a DP array also, right? So before keeping that, you just tell me one thing. You just tell me one thing. You already have this minimum length 5. So do you think you need to add the whole K? A point to be noted very here. Very important, very important. Just focus on me. Okay. You have what I told you, that K is nothing but 9 here. Okay. K was 9 here. Do you need to add 9 you to where you are adding? First you tell me to where you are adding. You are adding to this minimum string, right? The minimum string is already having a length of 5. Do you think K will remain K? What K will be nothing but K minus minimum length. Okay. You just, and how many more? The K is 9. Already you have 5. You need to add 4 more. You need to add 4 more characters. Okay. So you notice to what are you adding characters? You are adding to the minimum string. It is already of the length 5. So you need to add 4 more characters. Okay. So the K becomes essentially nothing but minus equal to minimum length. Okay. Minus equal to minimum length. And the things which I told you, just do it. We just do it like this. You just initialize a vector dp, and this dp has nothing but k length. It is initialized to 0 initially, and keep this ll. Okay, keep this ll. And what you need to do now, you iterate through all of the segments. Go through segments. Okay. So how can you go through segments? It's very simple. You just have this segment. You go through each element of segment. You are going through each element of the segment. Now, what do you need to do? You need to iterate through all the values of k. For every dp, you need to update. Okay, if you do not forget the formula which we derived it, okay, with proper intuition, I think this thing we derived, the total minus this thing we are calculating, dp0 plus dpi. So for all the loop from, I am going through segment A and I am also going through this I, and I am just adding these. Okay, I am just adding this into my dp, as I already told you why I am adding. So what would I have done naively is that naively I could have run another loop. Okay, I could have run another loop uh, for the summation. Okay, I guess you already know what is the summation. I could have run another loop for the summation. So what was that loop? Taking 0 elements, taking 1 element, taking these many elements, 1 element, 0 elements, 2 element, or till x elements. Because you see there are x things in the segment, as I had already told you, there are x things in the segment. You can add either 0 or 1 or 2 or x. Okay, so you can add these. So why don't you do a prefix array? I hope you know what a prefix array means, right? So if I write something like a dpi, I already told you, it was what should have been it ideally. It should have been a summation, right? But instead of the summation, I am doing a prefix. So this prefix is nothing but prefix of what do you say? Prefix of I minus prefix of x minus I minus x minus 1. Prefix of I minus prefix of I minus x minus 1. So what did I do here? You know, a prefix is, this is not at all difficult to you. This should not at all be difficult to you. You see what I am doing essentially is I am just calculating prefix from from this I to I minus x, and I already explained you that how we generally calculate prefix. We take one element before we add all the summation of the first prefix elements, and we just subtract it. So you sum from, this is nothing but sum from dpi. Okay, dpi sum of sum. This calculate this sum. Okay, this is nothing but it calculates this sum. It's very easy and simple. This should not be a difficulty to understand at all. This calculate this prefix. Okay. Now, if you don't know anything about prefix array, you should definitely learn about it first. Okay, I cannot help you if you are solving this problem, and I have already explained you in detail. Now, whatever be the case, I'm just doing the prefix thing now. I just keep the prefix array. Okay, you just keep the prefix array. Uh, what you do in prefix is very simple. You just do prefix of 0 equals to array of 0. not dp of 0. Okay, every time you do this, and you do from 1 to k. Okay, you just fill the prefix in whatever way you like. Okay, you have, I guess you have already done prefixes thing, so you just fill your prefix in whichever way you like. Prefix of I minus 1 plus dp of I. Okay, so it's very simple. So but you are missing a base case of dp here. Dp of 0 is 1. How many ways are there to form 0? I mean, with 0 additions, how many ways can I form the dp with 0 length? Okay, 0 length is 1. It's one way. I can do nothing. This is 0 length. So I hope you understood this. I hope you understood this already. And don't forget about the mod. Okay, you have put so much effort in understanding this problem, understanding the solution, and if you forget the mod, then it is very, I mean, very unfortunate. And you know how to add mod when there is a subtract? How many of you know? Just tell me. Okay, this is the way how you add mod when there is a subtraction. When addition, you do this. Subtraction, you just add a mod like this. Or you can do a little bit of pen on paper to understand with the basic mathematics of how this works. But it works, right? So you are removing invalid operations. Okay, you are removing invalid operations. So what is those invalid operations? It is nothing but the addition over all dp's, over all the elements of dp. So for int x dp, what you do? You do invalid equals to invalid plus. Okay, so you just add all elements of dp, as I had already told you that why you need to do this. Uh, these are the total invalid operations, right? Which is less than k. So I wanted to get something which is greater than k. Okay, so something which is greater than k. So I am doing something like uh, okay. So I am doing something like total minus something which is greater than equal to k, at least k. The question says at least k. So it means that it's greater than equal to k. It's nothing but total minus less than k. I had already explained you in this explanation. Still, I just told you. So these are the invalid operations which are less than k, but to be particular. So I just return something like total minus invalid plus mod or whole mod. Okay, so here also you are doing a negative operation minus. So you just put mod it in this way. Put mod in this. Okay. So I guess that's all, and this should work if I have not done any silly mistake or any small or logical error. So let me try to run this code and see if it works fine. It was a runtime error. Okay, so there is a mistake which I have done. So which mistake it is precisely? Can you guys tell me? Can you guys tell me what was my mistake? You see, there is a prefix of this thing. Okay, I minus x minus 1. What if this value becomes negative? I am following my logic very precisely. I am doing everything. What if there is an index error? So you just need to make sure that if I minus x minus 1 is greater than or equals to 0, then you only go with this. You ensure that there is no errors. Else if it is not, you just do dpi. You don't need to subtract anything, right? You don't need to subtract anything now. dpi is nothing but, okay, dpi plus this. So this will be just prefix of I. Okay, just do control z. Yeah, so if it is not, you just have one element, you have nothing to subtract it from, right? You just need the whole summation. So you have 0 to subtract, you have to subtract 0, nothing but. I hope you understood this. Okay, so if you don't understand any portion, just ask me in the comment section. Okay, let's see. So you see, it works perfect. It just works perfect. And I had already taken this kind of cases where also it had worked perfectly. So let's try to submit it and check if we are doing all correct. So you see, not only we are doing correct, we have a pretty good runtime complexity also. So you see, and memory complexity, I don't know why it is just 32% bits, because I am doing a simple 1 DP, and these loops you need to do. So what is the time complexity of the code? Just you go through it. This is nothing but O of n. This is nothing but O of n, and this is nothing but number of segments. You might call that number of segments is n, but it will be k, because if it is n, if it is of the order of n, then it would have fallen under this criteria. So k minus minimum length you are doing, k minus, so this will also be k, and this length is definitely k, is you understanding. So the time complexity of this code is nothing but O of n plus k square. Okay, O of n plus k square, and maybe plus k also you can do, because you are iterating through this DP again to add them all. So you just, this is the time complexity of the code, O of n plus k square plus k. You go ahead and check that it will match, it will match n plus k square plus k. So yeah, that's all for this problem. It was definitely a hard problem if you have not done similar problems before, but I hope I was able to make you this very clear. Okay, so if you have understood, definitely subscribe to my channel, and also write in the comments about the video. If you have any doubt, you can go ahead and ask that. Simply post that out. You can write, just type the comment section of the time stamp of the video in the comment section. Okay, so I will understand which portion of my explanation was doubtful to you. So that's all for this problem, and I hope your day goes really easy and not hard as this problem. So thank you so much, keep following my DP playlist also.